Okay, good afternoon, everybody. So we were talking about arrays in the last lecture, and we were talking about the subscripts at and asterisk, or the star. So remember that both of these things, if you use them as an array index, like that, or like that, expand to the list of strings, or sorry, the list of strings that are stored in the array. And whether or not you quote them, whether you quote the entire expression or not affects exactly what you get. So if you don't quote them, remember you just get the list of the array elements one after the other, each element separated with a space. Usually that's not what you want to do if your array elements can contain the space or special characters. Because when you, if that element, for example, if that element contains a space, then that list looks like it has 4 elements instead of 3, right, because of word splitting. So normally what you almost always want to do is you want to quote the at expression, the at subscript. Right? So dollar, brace, array name, square brackets at, and then quote the whole thing, because that produces the quoted sequence of strings, right, which is normally what you want to do. Right? Normally the strings, you don't want spaces or special characters to be interpreted as when you break it up, when you get each element out of the list, out of the array, sorry. If you quote the star, what is this called? The star subscript. If you quote the star subscript, then you get the string made up of the array elements, but the entire string is now quoted, which is normally not what you want, right? So you're treating the entire array as though it was one giant element, right? And so the examples below that part of the notebook shows you what happens when you use the various subscripts, right? So the unquoted star produces the following output, right? So notice you don't get a dog, a cat, and a fish, the 3 elements. You don't get 3 elements printed out, you get 6 because of the spaces in the individual elements. And the exact same is true if you use the unquoted at subscript. If you use the quoted at subscript, that's when you get the actual array elements, which is what you normally want to do. And then if you use the quoted asterisk subscript, that's when you get the entire array treated as though it were one big element. Right? So normally, almost always, you want the quoted at subscript. And the same is true when you're processing the command line arguments, right? So remember the command line arguments, it's just dollar and then at, right? Rather than brace array name. So it behaves the exact same way. Almost always you want the quoted at subscript. Okay, so bash arrays are funny. You can't, there's no requirement that your array elements be indexed starting at 0. There's no requirement that your array indexes be contiguous. So you can use 5, 7, and then 23 as your indexes. Because of that, because that can happen, and if you choose to do that sort of thing with your arrays, you now need a mechanism to get the actual indexes used by your array. Right? If you index your array sensibly, so 0, 1, 2, 3, 4, 5, then you never have to do this sort of thing. If you have some reason to use non-contiguous array elements, then if you want to get your array indexes, you use this notation here. So dollar, brace, exclamation mark, name of the array, and then the at subscript inside the square brackets. You don't have to quote this thing. So that produces the list of indexes used by the array. Right? And so for that first array here, remember round brackets around anything makes an array. So that is the array that has 1 element. It's indexed starting at 0. That's the array that has 4 elements indexed, 4 elements in it, indexed starting at 0. Indexes go up by 1. Right? 1 element index starts at 1. 3 elements, the indexes are 0, 1, and 100. Right? And so if you use this exclamation mark operator to get the indexes, you'll see the list of indexes printed out here, right? So 0, 0, 1, 2, and 3. That's just 1. And that's 0, 1, 1, and 100 here, right? So that is useful if for some reason you need to loop over the indexes of an array, and you're not using a contiguous sequence of indexes. Right? So for example, if you made your array of months like that, and you wanted to get the ith month using a loop, you could write it like this. Right? So for I in, and then, the list of indexes. Right? Now you can process each month, accessing it using an index. Right? You would normally not do this sort of thing. So you would normally not write the loop this way. Normally you would write the loop for each month m in brace months at. So normally you just write it like that, right? So normally you just iterate over the months directly. So you only need to do this sort of thing if for some strange reason you have to index by index. If you have to get the element by index, and if your indexes aren't in any sensible order, right? In this example again, if you really wanted to access the months by index, it would be preferable to write a regular for loop. So I is 0, I is less than 0, I is less than 4? 5, sorry, there's 5 elements, I guess. I plus plus. I guess I should just copy this. Control. Right, and you get the same output cases. Right? So if you're actually indexing sensibly, just use a regular for loop. Right? Don't bother with this exclamation mark syntax. Okay, if you want to join two arrays, then the operator is plus equals. Right? No spaces around the operator. So when you join two arrays, the thing you're joining must be an array. Right? So that thing there has to be an array. So, sorry, that's not precisely true. Yes, sorry, the thing on the right-hand side must be an array. So if you want to concatenate two arrays, so join two arrays together, right? You write array 1 plus equals and then the other array. Now, the thing is with the other array, you can't just write in dollar squiggly brace ARR2, right? That doesn't work, right? Remember why that doesn't work? Because that's short form for the first element of the array, right? The element of the array at index 0. So instead, you're forced to use this funny syntax here. So remember what that thing there does, right? That thing there expands to the list of elements of the array. Each element is quoted, right? Inside round brackets, that makes a new array, right? So you're taking an array, ARR2, you're unpacking its elements, and then you're putting it into a new array so that you can concatenate it onto the end of ARR1, right? Unfortunate, but that's the way it works. Right? There's no way to, as far as I know, there's no way just to concatenate ARR2 directly onto the end of ARR1. Right? If you want to add a single element to the end of ARR1, then just write round brackets around the element and use the same syntax. So ARR1 plus equals round brackets and then the element you want to append on the end. Okay. So we're going to unset A and B. So if A and B are defined, I'm going to remove them. The array A at index 100, I'm going to set to 0. Right? So I'm not starting at index 0. I'm going to start at index 100. B is the array 567. Right? I'm going to append the elements of B into the array A. Right? So when you do that, right, notice that the first element of A is considered to be the 0. Right? So that's the thing at index 100. Right? Then we append the 5, 6, and the 7, right? And when that appending is done, the indexes of those elements are 101, 102, and 103. Right? So here's the example where you want to append a single element onto the end of the array. Right? So so elem can be a variable holding any string. Right? So to append that element to the end of the array, quote the element, put it inside round brackets to make an array out of it, and then append it to the end of the array. So there's our months, January through April. I want to add May to the end of that array, right? So we write the string May inside. In this case, it doesn't have to be quoted because May doesn't have any funny characters in it. Put it inside round brackets to make an array, and then join that array to the end of months, right? And that produces the array January, February, March, April, and May, right? So the array concatenation operator is kind of handy, depending on what you're doing, but it's a useful feature to have. All right, so that read command that we saw in a previous lecture where you read from normally reads from standard input, but we read from a file using a redirection. You can also read the elements directly into an array, right? So the previous version of read that I showed you, we read directly into one or more variables. Instead of reading into one or more variables, you can read all of the elements into an array. And the way you do that is you pass in the -a option to tell read, hey, you're going to read into the array. And then you pass in the name of the array, right? If you want to, you can include a prompt using the -p option. So you can print a message to standard output saying something like enter a list of elements, right? And now read will read from standard input and put those elements into an array. Okay, so if you want to read, that one's not super interesting. If you want to read lines of a file into an array, then there's a command that will do that for you. And that command is called mapfile or also read array. They're both the same command. They just have different names, but it's the exact same command. So it reads one or more lines from standard input, storing each line as a separate array element. Right? So mapfile or read, what's it called? Read array, -tarr. Will read lines from standard input and store them into the array. If you don't put in the -t, you end up with a new line character attached to every element, which you normally don't want, right? So you get \n stuck onto the end of every element. The -t option removes the new line character from the end of each line, right? And so in the previous lecture or 2 lectures ago, we looked at the file that looked like that, and we used read to read in this file one line at a time, reading the fields into separate variables. I'm going to do the exact same example. This time I'm going to read everything into an array. Right. So the command is called mapfile. Right. Notice that with mapfile, you don't need a loop. It reads in the entire file line by line. Right. So students, where's that's the name of the that's the name of the file. Sorry, that's the name of the array. That's the name of the array. Right. That's the file to read from. Right. I'm going to redirect that file to standard input because mapfile reads from standard input. Right. And now I have the elements inside of an array. So if I run that, right, I'm going to print out the array one element at a time. Right. So remember, each line went into an array. Right. So the first line of the array was that line there. Right. The second line of the array was that line there. The third line of the array was that line there, and so on and so on and so forth. Right. So that's yet another way that you can read the contents of a file into a variable, in this case an array. Right. The nice thing about this is that you get all of the lines stored. In the previous example, we processed each line one at a time. When we were finished with a line, we lost the line. So if you need to do a bunch of processing to the elements, to the contents of the file, reading into an array is often the more convenient thing to do, right? You actually have the entire contents of the file in memory after reading into the array, right? And that's it for bash arrays. So like any other programming language that has arrays or lists, right, you can now write commands or functions that operate on arrays as well. All right, any questions about arrays? Note the strange or the unusual syntax, right? So just to quickly remind you how these things work, right? If you want the number of elements, right, the syntax is that, right? It's the hashtag symbol in front of the array name, followed by the square brackets, followed by the @. This is the strangest part about using the arrays, right? To get any information about the array, you have to use the name of the array, then the square brackets, then the @ symbol inside, right? Which looks weird, but that's just the way it is with bash, right? So the number sign in front of all that gives you the number of elements, right? The exclamation mark in front of all that gives you the indexes of the array. All right, we're just about done with bash, so we're down to one last topic, and that's functions in bash. So like other modern programming languages, you can create something that looks like a procedure in bash, right? So a procedure would be a function in Python, it would be a method in Java, right? Basically, you group your code into a single procedure that's got a name, and then you can call that procedure, passing in arguments if you'd like. Now, this is bash, so the way that you pass arguments and the way that you get the return value is weird, right? So this is very unusual compared to the languages like Python and Java that you've already studied, right? This is very strange that the way you do this sort of thing in bash. So you've got two choices to declare a function in bash, right? You can use the keyword function, and then you write the function name. You never write the parameter list. So this is one of the weird things in bash, right? So a bash function never has a parameter list, right? Just like a bash script never has an array of input arguments, right? It's just you just call it using the name of the script, right? So function, given function name brace, there has to be a new line here, command, and then there has to be a new line here. So the braces have to be separated by new lines, right? If you don't want to use the function keyword, then you write the function name round bracket, round bracket. But there's never anything inside the round brackets, right? The first version is legal, but generally discouraged because different shells don't understand that syntax. So all the shells understand the second syntax. So the second syntax is normally the one that's recommended that you use. You need a space or a new line after the opening brace. So there has to be white space here. And there has to be white space in front of the closing brace. If you're missing it, then you get funny results, right? If we click on this link here, is this going to work? Yes. So this is, hopefully this jumps out to shell check. Yes, right? So if you go to shellcheck.net and you type in that little script, it'll complain, right? And it'll even give you, if you look at the, this is the list of errors that you can, the list of things that shell check can look for, right? It tells you that the brace is only recognized as the start of a command group when it is a separate token, right? So in other words, you need a space between the brace and the E here. Right, so that's a problem there. Missing new line before the closing brace. Oh, this is edited. This used to look like that, right? And you need a space there. Okay, so how do you call a script? So how do you call a function? So the way you call a function is exactly the same way that you call a command, right? Except there's no options, right? So it's the name of the function, and then if you have arguments to the function, you just pass them in separated with spaces, right? So function, space, argument 1, space, argument 2, space, argument 3, and so on, right? Exactly the same way that you would call a command. Now, your function has no parameters, right? So that function greet has no parameters there, right? And it never has any parameters. So your parameters in your function are unnamed, right? And so the question is how do you get to the function parameters, right? Well, guess what? You use $1, $2, and $3. Right? So the positional parameters for a function are the arguments that are passed to the function. So here's our little function called test, right? Inside the function, I have 3 variables, param1, param2, and param3, right? And they get their values from the positional parameters, 1, 2, and 3. If you want the number of arguments passed to the function, guess what? It's stored in the positional parameter. It's stored in the special parameter hashtag, right? Just like the number of arguments passed to a script, right? So the number of arguments passed to the function is stored in $number or $hashtag, right? and the parameters or the arguments provided to the script are stored in the positional parameters. Right? So I'm going to call this test function using no arguments, right? Using one argument, 2, 3, and 4. Right? Notice there's 4 arguments here, but I've only got 3 named parameters in the script. Right? And then here, in the script itself, right? Now in the script itself, the number of arguments passed to the script is also in the is also in the parameter hashtag. So the question is this hashtag the same as this hashtag or not, right? And if you call the function and use hashtag here, does that change the value of hashtag down here? The answer is going to be no, right? So the positional parameters for the script are different than the positional parameters for every function. Right? So I'm going to call the, here we go. I'm going to call the script with 5 arguments. Right? The script itself is going to call test a bunch of times using 0 through 4 arguments. Right? So the first thing it does is it calls the function test. Then it processes the command line arguments. So let's see if we actually get the expected result. Okay, so we're going to call test with 0 arguments, right? So 0 arguments to pass to the function. Param1, param2, and param3 are all the empty string, right? Because, right, when we call test with no arguments, $1, 2, and 3 are not set, right? So param1, 2, and 3 all get set to the empty string, right? Hashtag, though, is 0, right? Which is what we're printing out there. Call the test function with 1 argument, right? Param1 is A, param2 and param3 are the empty string, right? 2 arguments, 3 arguments. Now with 4 arguments, we only got 3 parameters in our function, right? So the first 3 parameters are set. The 4th value that was passed to the function is discarded, right? It's not used by the function itself. So passing too many arguments is not an error, right? The extra arguments are just ignored, right? Now, what about the arguments that were actually passed to the script? Well, it looks like that is the right number of arguments, right? So we called the script with 1, 2, 3, 4, 5 arguments, right? The positional parameters 1 through 5 are arg1 through arg5, right? So the command line arguments stored in the positional parameters are different from the function arguments that you store in the positional parameters, right? The positional parameters for one function are different than the positional parameters for another function. Okay, so calling a function is not too bad. It looks like calling a command, right? Returning a value from a function is really messed up in Bash. So it's very strange. Again, the analogy between a function and a command still holds, right? And so a function also sets its exit status, right? So just like a command sets its exit status when it finishes, the function also sets its exit status. So you can use the exit status of a function as a return value, right? So the exit status of a function is equal to the exit status of the last command that the function executes, right? So if the last command that a function executes is if the last command that a function executes is successful, the exit status of the function is 0. If the last command that the function executes is unsuccessful, you get a non-zero exit status, right? You can use the exit command to exit. I think you can use return to set the exit status of a function explicitly, right? The problem with return is that the return value is always between 0 and 255, right? Even if you use a larger value, that number gets converted back to a number between 0 and 255. So this isn't super useful, right? This returning a value by setting the exit status limits you to what you can actually return from the function, right? So here's some function. It randomly sets its exit status to 0 or 1, right? So this is basically simulating flipping a coin, right? So remember, random is the variable that holds a random value, right? Every time you look at the value of random, it's different, right? right? So if I divide it by 2 and look at its remainder, right? If random is even, I'm going to return the value 0, right? If random is odd, I'm going to return the value 1, right? Again, remember, the largest value that you can return here is 255. The smallest value that you return is 0, right? So I'm going to call some function, and then I'm going to print out the exit status of the function, right? That right there is the exit status of the function, right? So 1, so I guess we randomly drew a 1, 0, et cetera, et cetera, et cetera, right? Okay, so if the value 0 to 255 isn't good enough for you, then you have to do something else, right? And the something else is bizarre, right? So the other thing that you can do is you can have your function print the answer to standard output, right? So you print the return value to standard output. So this lets you return anything, right? So I can print whatever string I want to standard output, right? And then you use a command substitution to capture the output. So when you call the function, you use a command substitution to call the function, right? This is admittedly strange. So here's max2, right? Max2 returns the larger of 2 values passed to the function, right? It's assuming you're passing in integers here, right? If you pass in strings, remember strings get treated as 0 inside of the arithmetic condition there. Right? So if the first argument is bigger than or equal to the second, we just print the first argument. Otherwise, we print the second argument, right? No return value here, right? We're going to print something. The exit status is always going to be 0 for this command, for this function, sorry, because these will never fail. Right? Okay, isInt is a little bit different, right? So isInt, we're going to use the return status for isInt. So isInt returns 0, or sets its exit status to 0 if the argument is an integer, right? It's going to set it to 1 if it's not an integer, right? $1, so that's the argument that's passed to the function, right? And now here's our main script, right? So our main script tests what is the number of arguments passed to the script, right? If it's 0, we just exit right away. Our script then uses the function isInt, right? Oops, sorry. Control Enter. Where is? Boop, boop. Okay. So there's our call to our function isInt, right? Remember how conditions work in Bash, right? A condition in Bash can be a command, right? The result of the condition is considered to be true if the command sets its exit status to 0, right? The condition is considered to be false if that's a non-zero exit status, right? What does isInt do? It sets its return value to 0. It sets its exit status to 0 if the number is an integer, right? Remember, that's our regular expression for an integer. Right? So if it's an integer, we're going to set high equal to the argument that was passed in. Right? Otherwise, we exit. So our script is always looking for integer arguments. Right? So we're going to assume that the high value is the value of the first argument. We're now going to process the rest of the arguments using shift. Right? So here's our while loop. Right? While the number of command line arguments is greater than 0, right, we're going to process the rest of the command line arguments. Every time we look at another command line argument, we're going to check, is the argument an int? And if it is, we're now going to compare the next argument to the current high, right? So our current maximum element is, our current largest argument is high. Our next argument is sitting in $1, right? Or in the first command line argument to the script. This time we're going to pass those two values to max2. Right? And max2 is going to print out the larger of those two values. Right? So we can reassign high by capturing the output with a command substitution. Right? Max2 prints a value, command substitution stores that value, and reassigns that value back to high. Right? If the next command line argument is not an integer, we exit with we exit saying we can't process this value, right? And then shift. So shift all the command line arguments one position to the left to process the next command line argument, right? By the time that loop is done, right, you have the largest command line argument, which we can print as high, right? So a whole whack of things are going on in this script, right? You've got a function here that sets it, that quote unquote returns a value by printing it to standard output, right? You've got a function here that returns its value by setting its exit status, right? You've got a function call there, right? That's the one that sets its exit status. You've got a function call here. Now this one prints its exit, its return value, so we have to capture it with a command substitution, right? And we've got the use of shift here to shift the command line arguments, right? And so max finds the max of those 4 command line arguments. So hopefully this prints 7 if I've done everything correctly, and it does. Right? Okay. The problem with doing that is that that's a command substitution. And the way that bash processes a command substitution is it launches a new shell to run the max2 command. Right? Launching a new shell is always more expensive than not launching a new shell. So if you can avoid the command substitution here, you should, right? Or you should try to avoid it here, right? So is there another way in which you can actually get the return value from this function? And the answer is yes, but it's equally as sketchy as the 2 ways that I just showed you, right? Okay, so the way variables work in bash is this thing called dynamic scoping, right? So this is very different than the programming languages you've used so far, right? And so no modern programming language uses this technique. It's very error prone, but it used to be common in much older programming languages. Okay, so dynamic scoping, so scope determines is a variable visible at this point in the program or not, right? Bash uses this thing called dynamic scoping, which means visible variables and their values are a result of the sequence of function calls that caused execution to reach the current function, right? So the variables that are visible to a function are all of the variables that were visible to the function that called this function, and so on, and so on, and so on, and so on, right? So that means if a script creates a variable a, and then it calls a function f, right? That variable a is visible to f, right? If f changes a, then whoever called the function now sees a changed value in a, right? Which isn't the way any other modern programming language works. Okay, so here is our, let's go down, here's the main body of our script here, right? So our script starts running at this point here, right? So a is set to hello, right? Hopefully if we print out a here, it's hello, right? We then call our function f, right? Now remember f, even though we didn't pass it a, f can still see a, right? So up here in f, right? It's legal to access the value of a, and in fact, you're going to get hello, right? You can reassign a up here, right? So a is not a local variable to f, right? That's not the way it works. A is the same a that was set in the main body of the script, right? So a now gets changed to f colon hello, and now we call g, right? So you don't call another function g. G also gets to see a, right? So it's going to print out a, which should be f hello. G makes a variable called b, right? Which is g goodbye, right? So return flow now goes back to f, right? So f now gets, f still has its own, f still has access to a, but now it gets access to b as well, right? So g created b. Flow of control went back to f, which means f now gets, also can see b now, right? So that b doesn't get destroyed or is not invalidated or does not go out of scope like it does in Python or Java, right? That b is visible to f. It's also visible to the main script, right? So down here, you can actually print out the value of b, right? And you will have access to b, right? Believe it or not. So if you run that script there, right, the following happens, right? So the main script sets a to hello, right? Inside the function f, a gets set to f hello, right? F calls g, b at the end of f, right? So f calls g. G doesn't do anything with a, but it does make a b, right? So f now gets b, which is g goodbye, right? The main script gets a changed value for a, and it can now see the value that's stored in b, right? And if you go through those steps there, that'll trace you through the sequence of calls that caused this to happen, right? So it's very strange. It's called dynamic scoping because variables suddenly appear as they are used, right? And then any other function is able to get access to that variable, right? So how do you use this to return a value? Well, you can do this in a few different ways, right? So you can, if your function wants to return a value, you just assign a variable that value, right? If that variable is visible to the caller, right? So if the caller knows that variable exists, then they can now use that returned value, right? Alternatively, you can create a new variable, right? And assign the return value to the new variable, right? And now whoever's writing the script has to know that this is happening so that the rest of the script can now access that new variable, right? Right? So either call the function, so when you call the function, at the point where you're calling it, you've got a variable already declared where you know the return value is going to be stored, right? Or the function creates and sets a new variable, and whoever called it needs to know that that new variable has been set, right? So here's max2, right? Max2 is not going to print its return value anymore. It's simply going to store the return value in high, right? So whatever high is, that's going to be the maximum of the two arguments passed to max2, right? IsInt is still going to set its exit status as its return value, right? So now when you call max2, right, you can just pass in the current high value and the next value that you want to process, right? The script will set high to the new maximum, to the larger of those two values, right? There's no command substitution needed here. All that happens is reassignment to the variable high, right? So that arguably simplifies things, but you have to remember that your function is actually changing high. Does it work? Yeah, it works, right? So you can type in any sequence of numbers there. It'll always return the largest value. Okay, if this sort of thing bothers you, it should, right? Imagine that you have a function here, f, right? Inside of that function, you have a loop, right? So that loop is looping using a for I loop, right? So for I in some sequence, right? If that function inside the loop calls another function, so it calls g, right? And g now has a for I loop, right? Guess what happens, right? When g changes I, that blows up f's I loop, right? So if g iterates over the some sequence of values I, after g is finished, the value of I that f gets is whatever the last value of I g used. So your I loop in your f function is now all messed up, right? So you have to be very careful about the fact that variables that are used in one function are suddenly visible in the next function, right? You write an I loop here that calls a function that uses an I loop. The I loop up here is probably now wrong, right? So how do you fix this problem? So Bash has this notion of local variables. They're not really local. They're sort of local, right? So you can label a variable as being local. Here, right? So I'm going to make a local variable called I and set its value to 100, right? When you write that, the value of I that's in the main script doesn't get affected, right? So that I is different than the I in the main script, right? If you don't make I local, right, notice you've got this loop here. It's supposed to run 10 times, right? So it's supposed to print out the numbers 0 through 9, right? Each time in the loop, it's calling some function, right? The problem is some function sets I to 100, so this loop only runs once, right? So I is 0, you print out 0, call some function, I is now 100, right? Now your loop condition is false, so the loop stops running, right? Very easy mistake to make, right? Your function here ends up using a variable that's the same as your loop variable. Everything blows up, right? If you make I local, that I is different from that I. So this one now runs 10 times, right? The problem with local is it's not really local, right? That I is local to this function and any function that some function calls, right? So it's not exactly local, right? So if you call some other function, right, the some other function can still see I, right? So I isn't truly local to this function itself, right? It's local to the function and any other function that's called thereafter, right? So this will print out 0, and then notice some other function gets the value of I, can see the I that was created by some function, right? Also notice that some other function can no longer see the I that was created here, right? So that local variable has hidden the variable that was declared down here, right? Some other function can also declare I to be local. So minus 99, right? Notice that as far as some other function is concerned now, I is minus 99, right? Some function's I is still 100, right? And the loop here, it still has its own version of I, right? But if some other function calls another function, that other function will see a value of I whose value is minus 99. All right, so that's how variables work in bash functions. It's very strange, right? And it will take a lot of, it becomes extremely hard to it causes errors that are very, very hard to debug in your scripts, right? So imagine I never told you that this is how it works, right? And you wrote that code there, right? And you ran your loop and it only runs once, right? You would never figure out what the heck's going on, right? So the fact that a function can see any other functions that appeared before it was called and can modify those values is extremely error prone, right? You can exploit this to return values from a function, right? So it's also useful, right? But it's so error prone that no modern programming language allows this to happen, right? Variables that are local stay local to the functions that they're declared in. That's not how it works in bash. So just keep that in mind when someone asks you to write a bash function, right? It's very easy to mess things up. All right, so that's basically it for bash in this course. You now know all of the, as far as I know, all of the basic functionality of writing a bash program, right? Sorry, that's not quite all. There are some other things we didn't touch on. But you know most of the basics now. So the next part of the course transitions into C, into the C programming language. And so I guess our next lecture, Wednesday, will be an introduction to the C programming language. All right, you do have an assignment coming out. It's not due till after reading week. It should come out tomorrow. So you can work on it before reading week, and then you get the week after reading week as well to complete it. Hello?
Question for the arrays.
For arrays, yeah.
Yeah. Can you use like last time in the